In this next video, we'll move into section Unit 3, which now we will discuss the trig functions at any angle. So as I kind of mentioned a little bit earlier, basically, I don't want to say this too strongly, but this sort of combines both Units 1 and Unit 2. Unit 1, we discussed angles of all different places, looking at the XY axis, discussing the idea of a standard angle. And then Unit 2, we introduced the right triangle aspect of the trig functions. But now in this unit, we extend that. So there's going to be a lot of ideas that get reused from Unit 2, and we'll definitely have to go back and not reintroduce, but see how we integrate aspects of Unit 1 into this. So where does all of this start? Well, this starts off with a discussion of the unit circle. Now, I do want to quickly point out, the book does this slightly differently than I do. The book starts off just looking at any circle in the XY axis. I'll show you how that applies, but it's so much better to get used to this idea of a unit circle. So what is the unit circle? Well, now we're back to our standard XY axis, and we're going to look at a circle whose center is the origin and whose radius is exactly 1 unit. Hence, that's why it's called the unit circle. Circle centered at the origin with a radius equal to 1. So with this setup, if this is the origin, well, if I only am going to the right, which is what happens right here, and I go 1 unit, that means the XY pair is 1, 0. If I only go up to take me to this point, that would have XY pair 0, 1. If I only go left, that would give me an XY pair of -1, 0. And if I only go down, that would give me an XY pair 0, -1. I'll come back and point out why these 4 values are useful in just a moment. But for right now, let's see that if we start off with a standard angle, so starting from the positive x-axis, using our positive angle, so using the counterclockwise orientation, and that would be angle theta, and that connects me to some random XY pair on this circle. Well, let's notice what we can do here. I can make this into a right triangle. Now, whenever we get right triangles inside the XY axis, you could always do that by taking your point and going either straight to the Y or the X axis. To make all these definitions work and be the same all the time, you will always go to the X axis. So there's a right angle. Again, I'm getting a little tight inside here. Let me exaggerate this so we could just see this side. So there's theta. There's a random XY pair. But look at and remember how XY pairs work. If I'm thinking about how do I go from this point, the origin, to this random XY pair, well, X tells me how far left, right I go, and Y tells me how far up, down I go. So therefore, this side of the right triangle, again, now I'm ignoring all this part out here, just looking at the triangle, this side would have distance X, this side would have distance Y, and because it's a unit circle, the radius is 1, so the hypotenuse would line up and be a radius in that circle. So there is a nice right triangle situation. Here's the big point, everybody. Now, if we look at what happens when you look at sine and cosine in this situation, well, sine is opposite over hypotenuse. Well, in this situation, the opposite is y, the hypotenuse is 1, so y divided by 1 is just y. And then similarly with cosine, we're looking at adjacent over hypotenuse. Well, the adjacent side is x, the hypotenuse is 1, so x over 1 equals 1. That may not seem like a very big deal, but what that shows us is that every xy pair in the unit circle, x directly corresponds to the value of cosine at angle theta, and y directly corresponds with the value of sine at angle theta. Now, I did that nicely in the first quadrant. In just a moment, I'll show you how that extends into the other quadrants and the little extra, I don't want to quite say consequences, but the little extra facts, what else happens when we get outside of that first quadrant. But just before I do that, I just want to show you the tiny little difference between what I did here and what the book did. The book doesn't start off with this as a unit circle, so they just generically have this as r. So they get sine as y over r, cosine as x over r. And again, that is 100% true, but this is what's going to be more useful to us. When we have to deal with another circle, with a circle that has a bigger or smaller radius, well, we'll deal with that and we'll still use our whole right triangle facts. This is a situation, like I've mentioned before, we can memorize a whole new boatload of facts, or we can just memorize this new tiny little adjustment, this little extra extension of something we already know, and then know how to apply it when it goes into other slightly different areas. And by that, I just mean when we get into the other quadrants. So that's the only difference. If we made this, again, a bigger radius, if I had a circle with a bigger radius, this would be y, this would be x, but now this whole thing would be r, but it's all those similar triangles. The value of this big y over this r would be the same ratio as this smaller y over this smaller r. And so again, instead of doing the big memorization, let's use the one that's useful. How is this useful? Well, now, like I said, let's get into the other quadrants. So what happens if the terminal side of theta ends up over in the second quadrant? So there's theta. I would still make my right triangle to the x-axis, but now notice theta is no longer inside our triangle. So in just a little bit, we'll start looking at this interior angle. I'm going to use an alpha. The book uses a theta prime. I really don't care for that. We're already using theta as the main angle, so then we start using a theta prime next to it. It's so easy to miss that prime, and now you're just looking at thetas everywhere. So I want to use a different value, so I'll call it alpha. And alpha is what we call the reference angle to theta. And the reference angle is always the angle to the closest x-axis. But now that we have that set up, this is still an xy pair. This would still be x. This would still be y. If it's a unit circle, this would still be 1. So now what happens is that now when we start thinking about sine and cosine of theta, we still get the same xy results. It's just in this case, now that we're in the second quadrant, x is negative. We went left from the origin instead of right, therefore we're getting a negative value for x. Y is still positive. So in this situation, we can still get our trig values by focusing on this and establishing this is the opposite side, this is the adjacent, and there's our hypotenuse. But we could still go back to this basic definition, but we just have to realize that now those ratios, now because of the fact that we're incorporating the extra aspect of direction, now we get the possibility of our answers being positive or negative. Okay? Up until this point, every time we've dealt with the trig functions, we've always gotten positive answers. And if you go back to Unit 2, and we'll do this in just a moment, I promise you, I gave you a trig value, told you theta was acute, and then asked you to find the other trig values. And I said, don't worry about the theta is acute for right now, but that's why I needed to include that. If theta is not acute, we might be in a different quadrant. And if we're in a different quadrant, we have to have the possibility of positives and negatives. So how does that work? Again, the book goes pretty slowly, looking at every trig function as we go through quadrant 1, quadrant 2, quadrant 3, quadrant 4. But coming back, and I could keep doing this, everybody. If we go to the third quadrant, that is theta, but that would be my right triangle. And now alpha would just be this little angle, okay? And if we're in the fourth quadrant, that would be theta, and that would be alpha. And we'd be looking at that as a right triangle. Let me get my alpha in here. So every single time, the closest x-axis, it doesn't matter if the angle, the terminal side, is out here, so I'm close to the y, doesn't matter, I still go to the x. That is always the situation. If this angle was down here, doesn't matter. This would still be your alpha, would still be your reference angle. We're always going to the x-axis when we are setting that up. But now, the consequences. In a moment, I'll give you another acronym. It's a little similar to SOHCAHTOA, and a little clever way that people try and memorize the results, and that's ultimately what we need here. Okay? So, what happens in quadrant number 1? Well, if you're in quadrant 1, doesn't matter what point, you're here, 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 anywhere over here, anywhere in quadrant 1, your x value is positive and your y value is positive. Therefore, both sine and cosine are positive. Think about how the other trig functions relate. Well, tangent is sine divided by cosine. Well, if sine is positive and cosine is positive, so is tangent. The other three are all 1 over one of the other trig functions. Well, if all the trig functions are positive in the first place, 1 divided by a positive is still a positive. So all that points out that if we're in quadrant 1, all of the trig functions are positive. That's the big result. That's the big thing so far. But now, and again, that's why we've never worried, because every angle we've dealt with so far has always been a quadrant 1 angle, so therefore everything's been positive. And any of your word problems, your direct applications, you would be drawing regular right triangles, so again, you're not worried about negatives. But now, getting deeper and understanding the trig aspects, now we have to understand the other quadrants. So we get to quadrant 2, like I was just saying and showing you over here, you went to the left to get into quadrant 2 and then went up. So an x value over here would be negative. The y would still be positive. So sine would still be positive, but cosine would be negative. So by putting something greater than 0, that's the same thing as saying it's positive. Any value that's greater than 0 is a positive value. Anything that's less than 0 would be a negative value. And that's what we're getting. But now all the rest of the consequences. Well, tangent is sine divided by cosine, so a positive divided by a negative would then be negative. And most people stop there, because again, the other three are all the flips. Well, if you flip a positive value for sine, for cosecant, it'll still be positive. If you flip a negative value for cosine to get secant, well, if it's negative for cosine, it'll still be negative after you flip it. And then same thing for tangent. So what a lot of people start doing here, instead of writing every single trig function for every quadrant, let's focus on which one is positive out of your 3 primary, okay? Out of the 3 primary trig functions, this is the only one that's positive. By default, the other 2 are negative. Okay, so let's keep going into quadrant 3. Now, I went left to get into quadrant 3, so x cosine is still negative. I also went down to get into quadrant 3, so the y value would also be negative. Sine is negative, cosine is negative, and then when you divide those two to get tangent, tangent will end up being the one that is positive. And then again, sine and cosine are both negative. And then the last piece here, fourth quadrant, x is positive. We went to the right, and then we went down. So we went to the right, x is positive. We went down, y is negative. Cosine is positive. Sine is negative. And once again, when you divide a negative and a positive, you get a negative. So tangent would also be negative. Therefore, cosine is the only trig function that is positive here. Those are the basic results. So we'll get some practice with this in just a moment. We're going to start a little slow, just practicing establishing what quadrant we're in based on positive and negative facts, and then we'll extend that and do a couple of problems to demonstrate how we fully use that. But how do you make those decisions? We've said all the results, but what are the quick ways? Most students use one of two options. Either they just stick with the sine and cosine values, okay? They just stick with, they always remember, sine is y, cosine is x. So as I was doing for each individual example, they do that in their heads every time. They go, okay, well, if sine is positive, they know y is positive. And again, we're going to have to work backwards. You're going to have to do both ways. I tell you what quadrant we're in. We decide positive, negatives. I tell you the trig functions, whether they're positive or negative. You tell me what quadrant. So if I tell you sine is positive, they say, well, y is positive. I must have gone up. That means I'm in either quadrant 1 or 2. If I tell you cosine is negative, they go, well, cosine is x. So x would be negative. If I go left, that means I'm in quadrants 2 or 3. That's how a lot of students do it. It's all about thinking about sine and cosine and connecting them to the correct y and x. One other quick moment focusing on that. Come back here. The boundaries. We'll come back and use this again, but I just want to point it out while we're right here. X is cosine, y is sine. Go back to that reference angle table. This would be angle 0, and at angle 0, cosine would be 1 and sine would be 0. And then at 90 degrees, this line would represent 90. I'm not in a quadrant, I'm on the boundary. So how do you deal with these boundary issues? You use these xy pairs. X is 0, y is 1, therefore at 90 degrees, cosine is 0 and y is 1. At 180 degrees, x is negative 1, y is 0, therefore cosine of 180 is negative 1 and sine of 180 is 0. I mean, at least these are very quickly confirmed on your calculator, and unlike some of those other values that are very ugly, messy decimals, 0, 1, and negative 1, very friendly. Again, you should understand where it's coming from, but that's certainly a spot where some students get a little boost from their calculator. Okay, so now, back down to here. So option 1, people think about, again, just using the appropriate x and y. Think about every individual situation that you're given and use that. And again, you could either figure out what quadrant you're in or vice versa, figure out the appropriate positive or negative for your trig function. But the second option, and our book mentions this at the end of all this, is this little mnemonic device. All students take calculus. Some substitute chemistry instead of calculus. But what that's supposed to bring us to is the letters A, S, T, C. And that if you go around starting in quadrant 1 and go A, S, T, C, how is that supposed to help you? This is telling you which of the 3 primary, again, this only incorporates sine, cosine, tangent. We have to always think of the 1 over aspect to consider our cosecant, secant, cotangent value. So what we're getting here is this tells me which of the primary trig functions is positive in that quadrant. So A stands for all. All the trig functions are positive. S stands for sine. Only sine is positive. So therefore, if you're dealing with cosine or tangent, that is not sine, and the trig function is not positive, therefore negative. Quadrant 3, the T. Only tangent is positive. Therefore, if you have sine or cosine in the quadrant 3, you get a negative value. And then the C stands for cosine. In the fourth quadrant, only cosine is positive. If you have sine or tangent, you're getting a negative from that quadrant. That's how we're supposed to understand that. Okay, so now we can start testing. We could start asking the question, in what quadrant? Let's start off number 1. In what quadrant are we in if sine of theta is less than 0 and cosine of theta is greater than 0? Well, as we go through and do this, I know some people can do this very quickly in their heads, but I'm going to just try and take it nice and slow. Individually, each one of these pieces will give us 2 quadrants as possibilities, and then the quadrant that satisfies both is the final quadrant. So let's start over here, because I started with this one that cosine is greater than 0. Well, all are positive in the first, so that includes cosine. And cosine is also positive in the fourth, so this gives me the 2 possibilities of the first or fourth quadrant. But over here, sine is negative. Well, again, if you're using the ASTC, sine is positive in 1 and 2, right? A is still the all, and S gives me where sine is positive. But I want sine is negative, so it's the other 2. That would be quadrants 3 or 4. And the fourth quadrant works for both of these. So that's how I know we are in quadrant 4. Now, I mean, others, I did it, that was more the ASTC approach, but plenty of others, the XY. Y is negative, I went down. I'm in 3 or 4. Cosine is positive, therefore X is positive, meaning I went right, and I'm in 1 and 4. We just did the same thing. I still figured out the 2 possibilities for this and the 2 possibilities for this, and once again, they match in the fourth quadrant. Let's do that again. Let's get some more practice with this. Number 2. Let's say if cosecant is greater than 0 and tangent is less than 0. Again, don't let these inequalities fool you. The less than greater than is all just positive negative. Greater than 0, cosecant is positive, but cosecant is 1 over sine. So that's kind of the trick in this one. I didn't give you one of the 3 primary trig functions here, but think about it. If cosecant is positive, that implies that sine is also positive. You took one of the non-primary trig functions. Now, these don't have the same value, but this is where we've seen things like if cosecant, let's not just say positive, let's give a numerical value. If cosecant is positive 5 over 2, then sine would be 1 over that, and that would still be positive. Specifically positive 2 over 5, but the point is a positive here for cosecant would still lead to a positive here for sine. And now, whether you're an ASTC person, you go sine is positive, well, that's quadrants 1 and 2. Or you use the Y and say, when is Y positive? When you go up, and that puts me in either quadrant 1 or 2. For tangent, well, again, that's where ASTC helps. Some people can still fight their way through with Y and X, but that's a nice reason to include tangent here. Because now you got to think a little bit, well, okay, I already used this. So tangent is less than 0, so sine divided by cosine has to give me a negative. Well, if sine is already positive, that tells me that cosine has to be negative. But look at how nice it is to incorporate this. Tangent is greater than 0 in 1 and 3, therefore tangent is less than 0 in 2 and 4. This time quadrant 2 is the one that works for both. So definitely some more in the book. And again, we'll get some more practice doing this idea. This is just supposed to be a little quick to help get us started. But now let's just do a few other little things to go with this. There's one minor aspect I should point out. I think there's one problem in the book. They just give you the unit circle, so you could just easily start filling in just your x's and your y's, but you could always think of the right triangle to help you out. But I believe there's one problem where you're missing a value. So let's quickly talk about that. What do I mean by that? I'm saying you're missing a value. They talk about this point is on the unit circle in the second quadrant. Let's do in the fourth quadrant. Actually, no, I'm sorry. My next example will be the fourth quadrant, so let's do the third. Point is on the unit circle in the third quadrant. Find the missing coordinate. So over here, I drew a point. So here's my point P. It's in the third quadrant. You have the X, you don't have the Y. So you can still draw a right triangle in here. And they're trying to kind of float you around this. But that's, again, right triangles are always there. So we can realize this is 4/5. It's the unit circle so that the radius is 1. And you're looking for this side. So realize this is basically Pythagorean theorem, but the only extra catch is at the end. If you just use Pythagorean theorem, blank squared plus 4/5 squared, literally it's minus 4/5, but when you square it, it's positive, equals 1 squared, which is 1. You do a little work, you'll get 16 over 25 here, subtract that from both sides, blank squared, you'll get 9 over 25. This is where we've seen this several times. Technically, when you get the square root here, the square root of 9 over 25, both top and bottom are nice here, nice perfect squares. But in all right triangle problems up to this point, we've always said ignore the negative because we're looking at distance. But here, now that we're back on the XY axis, now we have to realize, well, is it positive or is it negative? And the point is that since we're in the third quadrant here, we should just realize that the negative would be appropriate for this one. And that would be your answer. So, like I said, it's really something we've done before, but just pointing out that if you're in the unit circle, that you automatically know the radius is 1. That's the most common thing people don't see. Even whatever way they try and approach this, oftentimes they try and draw a right triangle, but they feel like, well, wait a second, I don't know anything. I only have one piece. I need an extra angle or I need an extra side. And they forget that because it's the unit circle, you also know the radius, which ends up being the hypotenuse. So that's a quick one. But now I really want to get back to the bigger problems using the unit circle, incorporating all aspects. So we're not just thinking of standard right triangles, we're thinking of trig functions at any angle. So now let's kind of repeat a problem we've seen before. If we are given, I think we used cosine in earlier, so let me use sine this time. I don't want you to see it as the exact same problem. I want you to have fresh examples, but to realize it's similar. It's very similar to something we've done before. So let's say we are given that sine of theta is negative 3/4, and we are given that secant of theta is, let's go less than 0. Let's find all the trig function at theta, and this is another exact answers only. So calculators aren't helping us here. How do we proceed and do this? Well, again, that's where we've said before. If you know one trig function, you can make a right triangle to get the other values, but the piece we were missing before is what quadrant are we in? So earlier when we did this, and the second piece of information I just said, and theta is an acute angle, that's where you would now be able to say, oh, if theta is acute, that means the angle is less than 90 degrees, we're in the first quadrant. And in the first quadrant, all Trig's functions are positive. So that problem is completely correct. All of them were positive when we did that. But now, there's the extra consideration. Sine is negative. We are in quadrants 3 or 4 if sine is negative. Well, secant is also negative, which implies that cosine is also negative. That happens in quadrants 2 or 3. We are in the third quadrant. That's the extra little component. And that's what we were just doing a moment ago. Just a moment ago, I didn't tell you the value for sine, but if I said if sine is less than 0 and secant is less than 0, what quadrant are we in? This problem doesn't ask that, but that's an extra consideration that we still have to make. So now that we have that extra consideration, we don't have to draw the triangle in the third quadrant, and I'd actually recommend against doing that. Just don't forget at the end, we're going to have to think about the quadrant to get the appropriate plus or minus, but I'm still just going to make a right triangle. I'm going to stick theta in here. Technically, that would be alpha if I was in the third quadrant, because, again, realistically, that would be theta in the third quadrant. So you'd have to think about your alpha. But again, that's another nice reason to just not have to worry about that. We already wrote we're in the third quadrant. We will use that. The negative has served its purpose. Okay, I strongly recommend the second part. Don't put negatives on triangles. Where should the negative go? Negative 3 over 4 is the same as 3 over negative 4 is the same as negative 3 over 4. The negative in the top, the negative in the bottom, a negative out in front, it's all the same thing. So if you really want to try and stick the negative, where should it go? Does it go, well, if it's this, the negative would go with the opposite side. If it's this, the negative goes with the hypotenuse. If it's here, well, you have to decide where to put it. Again, my advice, let the quadrant determine the positive, negative, and just use the numerical values. So here, the opposite is 3, the hypotenuse is 4, a little Pythagorean theorem. Again, the 4 is the hypotenuse, so make sure that's the side by itself. When we solve this, that's a 9, that's a 16, so we'll get 7. So the square root of 7 is as good as it gets here. Triangle for the values, quadrant for the plus or minus. We already knew sine was negative 3/4, but again, some people still like to do it again to confirm. Quadrant 3, yep, sine should be negative. Negative what? Opposite over hypotenuse, negative 3/4. Cosine, third quadrant, cosine would be negative. Tangent's the only one that's positive in the third quadrant. So again, several pieces, we even set it up here as a second spot, but that's, multiple reasons why we know cosine is negative. Negative what? Adjacent over hypotenuse. So I get negative radical 7 over 4. And then tangent. Tangent is the one primary trig function that is positive. Now, if you don't put the plus sign, that's fine. We understand it's there. But I like to recommend it so it's like a little confirmation that you didn't forget to check the sign. You knew these were negative, so those have to be shown. But now you're showing it's positive. It's more confirmation for yourself that you've thought about it and determined that it's positive. Positive what? Opposite over adjacent. And if we clean that up, we get 3 radical 7 over 7. Don't forget about the others, but you've done all the hard parts. Again, we say this so often, but not to forget, once you have these 3, it's all just flipping. What's cosecant? Well, you flip this, and when you flip, it still stay negative. 1 over negative 3/4. You flip, it's still 1 times negative 4/3, negative 4/3. Secant, you'll get negative 4 over radical 7. So let's just rationalize that. And then cotangent, we'll get positive this time. And again, don't flip this one to make your life easy. And there's your final answer for cotangent. Okay, that's definitely a tough problem. Some students have a tough time doing that even without worrying about the quadrants, even just going back to when we did things like that in Unit 2. So that's definitely a bit of a tough problem. So let's do it again. Again, can't say it enough, everybody. Plenty of good extra problems in the book itself, in the unit, and in the homework, so don't forget about those. So let's move along. Let's do another one. This time, let's say we are given, let's do secant of theta equals, we'll do 7/5, and sine of theta is less than 0. Same thing. Find all the trig at theta, exact answers only. Same thing. Well, right off the bat, a lot of people here, secant not quite as friendly, so let's make it into cosine. If secant is 7/5 positive, that implies cosine would be positive 5/7. The fact that cosine is positive, we're in quadrants 1 or 4. The fact that sine is negative means we're in quadrants 3 or 4. We are in the 4th quadrant. Quadrant, there's my plus or minuses. I'll use that. I mean, again, look already. I already know cosine is positive, sine is negative. Some people in this one, you're lucky enough to be getting these two. So again, you could still use the little other things to rationalize the other plus or minuses. But the best way is to make sure you know it's coming from the quadrant. Now make the triangle. There's my theta. So adjacent is 5, hypotenuse is 7. So I would get blank squared plus 5 squared is 7 squared. 25, 49, subtract the 25. You get 24. Not a perfect square, but one we can break down. If you just leave that as radical 24, it's not a huge mistake, but we want to do better. The square root of 24, well, that's 4 times 6. So 2 radical 6 for the opposite side. Not trivial, everybody. Figuring out the quadrant, getting your right triangle set up, that is not trivial at all. There's a lot of work that's going into that. But now, again, we push along. I mean, you could argue that now you knew cosine. Remember back in Unit 2, we showed, hey, sine squared plus cosine squared equals 1. You could still do that for sine, but you still have to take the quadrant into consideration. At the end, the value you get for sine, you have to think about plus or minus. Here, you'd have to realize, oh, this is telling me it should be negative. So again, little other differences, but you're still making all the same considerations. Okay, so if we finish this, sine of theta, 4th quadrant, sine is negative. Negative what? Opposite over hypotenuse. We get negative 2 radical 6/7. Cosine, well, we already have that, right? And again, we needed that. A lot of us can't do much with secant. So the first thing you should do is know, well, if you know secant, flip it, you know cosine. So that one was basically already done. But you could always, again, start fresh, confirm that you didn't make any little mistakes in your setup. 4th quadrant, yep, you're going to the right, cosine is positive, or your ASTC, the C goes with the 4th quadrant, another reason why cosine is positive. Adjacent over hypotenuse, there's your 5/7. Tan is negative in the 4th quadrant. If cosine is the only positive one, then tangent is negative. Negative what? Opposite over adjacent, 2 radical 6/5. I'm going to be a little short on my room here, so I'm just going to give you the final answer. I'll say everything, but I'm just going to have to rationalize a little bit. Cosecant of theta, still going to be negative. Flip it, 7/2 radical 6, top and bottom times radical 6. You'll get 7 radical 6. In the bottom, the rad 6 times rad 6 is 6. But don't forget the 2 is still there, so I end up with a 12. So there's cosecant. Secant, no problems there. Remember, that was the first one that was given, so definitely easy confirmation. And then similar here for cotangent. Flip, still negative. 5 over 2 radical 6, top and bottom by radical 6. And same thing, in the bottom, 2 times radical 6 times radical 6 is 2 times 6. So there's your 12. Okay, a lot of work. Very good so far. Still have several things to consider, but we'll start getting into those in part 2 of this video.